Hello everyone, welcome back to my channel. In this video we are doing the second part of the data augmentation part. So in the last video we did the first part where we slightly blurred the images, and now we are making them a bit bolder or less bold. So don't forget to like and subscribe to my channel, and let's get started. So first thing we want to do is to add something called kernel, which is the NP1s, and we want it to be 5 out of 5, and we want them to be NP unit 8. NP.unit 8. And then wait, let me comment this display. We don't need them for now. We will probably use them later. So what we need to do next is the CV2 dot arrows. Then we enter the image, and we enter the kernel, and then iteration. Iteration. Iterations. Let's say equal to 1. So I have to assign this to a new variable. So image dot erosion. So we are basically bolding the image. So the image that you see here will be a little bit bolder, and we can make them a bit more bolder with iterations equals to 2. But we will not go to 3 because that's gonna be a bit very hard for the deep learning model. It will be too much. So we copy this. So image erosion, you can rename this to 2. So we get iterations equals to 1, and then for the second one we have iteration equals to 2. And then what I want to show you is the image dilation equals to CV2 dot delete, and then exactly the same parameters. So image kernel and iterations. So for now, put equals to 1, and then equals to 2. So image iteration equals to 2. Okay, so now we are going to explore them one by one. So first we will have a look at the second erosion, because that's where we can see the most difference. So image erosion 2. Okay, let's run that. Module full. NumPy has not attribute uint8. Oh, I just misspelled it. It's supposed to be u integer 8. Okay, so let's run this. What now? CV2 has not attribute erodes. Why is that? Oh, sorry, it should be erodes instead of erodes. Okay, now it should be alright. Okay, so you can see that the ones are a little bit bolder, and as we have almost 60 of them that are blurred, we have to scroll through all of them, and even the 2 is getting bolder than we had last time. Okay, I will just now have a look at the dilation. And actually, just for now, I will fix this, because I just want to debug and not to train the data yet. Actually, I need to interrupt this and rerun. Okay, so this is getting very thick. So you might think that the 2 is too thick, but it should be alright. You don't have to worry too much about that. Okay. So now let's comment this out, and let's change it back to 30. And now what we will do, as I think we are ready with the data, so now we will create the deep learning model. So in order to do that, let's create a list which we call training data, equals to empty list. Actually, I just misspelled training. Yeah. So for every image, we will train data dot appends, and we will append actually a tuple of the image itself and the class number that we had that we have earlier in here, which is the number of the digits. And we will actually do the same. And don't forget to rename the variables. So erosion 2, dilation, and dilation 2. So we will do the data augmentation. So we just call the thing, and just below that, we will print the length of of this training data. So len. Actually, we do this instead. Okay, so now we can run this out. Okay, so we have 2,700 data in total. Well, to be honest, it is a very small number for a data set, but we are working in printed digits in the exact format way. We are not doing, handwriting digit or printing digits in different fonts. We are using the same font because in the Keras library, I don't have it imported here, but we will import soon. We can access to a handwritten number data set, and this contain only 6,000 data in total. So I think because we have approximately 3,000 data, so almost half of that, I think we should be all right with that. So now let's create the deep learning model. So most of it will be, I'll just copy from what we did the last time with the deep learning. You could check the link into the description if you are interested. Let me instead some more cells below. So we have the print left training data. We don't need this because we have it above. So we need to import random and random seed. We just pass the number of the length and random shuffle the training data. So we are doing the random shuffle. And however, I think there is a bug inside the random. We don't have the exact same random, and these can modify slightly the deep learning, but we are not going to worry about that for now. And then we are just creating the data, and then we are just displaying some features and the label of the training data, and we are just doing that for the 10 first round because we are not going to print 2,700 data. So next we will have the image chase, which is set to 100. We have the X array and the Y array, and in this loop we are appending the X for the images array and Y to the label, I mean the digit value. And in the X we are reshaping the array because we can't put directly a multidimensional array into a deep learning model. And then we all set to float 32, and we all divide by 255. So each value will be between 1 and 0. If the original value of the pixel is 255, which is the maximum and which is also equal to white, then it will be at 1. And if the original value of a pixel is at 0, we'll have 0 divided by 255, which will be 0. And everything between these two numbers will be between 0 and 1. That's just because the deep learning is more comfortable using data between 1 and 0. And then we have the Y, so nothing pretty much to do this. We just need to NP array Y, that's it. And then we have the final thing. We have the model equals to TensorFlow Keras.model sequential, and we're just building multiple layers for the deep learning. And then we have the model adds, we want a layer of 10 because we have 10 outputs, which are the digits. And then we can compile it and model fit with 3 epochs. So let's run everything now. So import random. Alright, I just realized that I have misspelled training data at the beginning of the code. Let me replace everything. Normally you should not do that. You should always check whether the variables matches or not. If you are using PyCharm, I think you won't really have this issue because it will give you a warning before you run the code. This as well. Okay, I think we should be good. So I need to rerun the training data and then import random. So this is the first 10 values of our random shuffle training data. And then we have the image size, have to set that, and then we have to compile the model. Oh yeah, I have completely forgot that. Let me add the libraries for the deep learning. Okay, so I have added these libraries, so TensorFlow STF, statistic, and also all these Keras libraries. You can, I think it's exactly the same as the deep learning we did last time, a couple of videos ago. So let's run everything. What? Okay, we have a mistake of the images. That's quite strange.
5 minutes later.
Okay, I have found the problem. When I call CV2 IM reads, I need to explicitly tell that I'm read to grayscale because it's not because a grayscale image that you have saved is completely grayscale in OpenCV. You have to explicitly tell, otherwise the pixel will be at each pixel will be a tuple of 3 values, and in our case, to get the deep learning working with the arrays, we want only one value, which is the grayscale image. So let's rerun that again. Okay, now this seems to be better. Now let's compare the model. Okay, so it has a pretty high accuracy. I'm just worrying about if it is not overfitting, but even if it does, I think it should be okay. As I said, digits are not really a big matter. They're just very, very similar. So now we are ready to try this model. Actually, we need to save it, and then after we will be ready to use this model to test if we get the right results of a brand new Sudoku quiz. Alright, so we do model.save Sudoku model YTB-H5. So we had this model before, but we seen that it was terrible, so we are not keeping it. So in this notebook, we are overwriting it. So let's save the model. Okay, now it is saved. So in order to test it, we will take the same code as we have for the image picker. So we make a copy of the notebook. So here's the copy of the image picker. So we can get rid of this. We don't need the grid anymore. We want it to get the contours, etc. Okay, pretty much. So the only thing we need to modify is to pick image. So by the way, I will rename it into classify. And let's not forget to modify the top one. Okay. We can delete that. We don't need this anymore. Right, okay, so we have cv2.iamWrite data drop plus str thing, and that's the part where we need to delete. Okay, so in order to go faster, let me copy the contours detection and the Kenny as well, so that we can start from there. Okay, so we have the image Kenny equals cv2 Kenny. We'll put cell instead of image because we don't have it. And then basically everything is the same. Okay, let me get rid of this. Let me change the image format so we can predict using the deep learning model. Alright, I have already preset the algorithm to detect the thing. I actually took from the operational version of my project. So image num, that's our new variable, equals to image to array. let me see if we have it imported the library. No, we didn't. Let me copy it from the data from this notebook. Okay, should be alright now. So for the image to array, let me put the image rectangle inside, and I think that's pretty it. And then we call the Sudoku model YTB. Okay, so I guess we can start running it. And by the way, let me add the display image because I really want to make sure that it is the right number to associate with the image. So for that, we go back to an old notebook, we copy the PLT I am show, and we paste it here. So we'll first see the image and then the detected inside, the detected value just below that. And then we have even the probability, which is the maximum probability that we have. Well, obviously it is obviously the maximum because in deep learning the maximum is set as the true value. But we are just interested that if it's very sure that it is this digit. For example, if you have something right, but the probability is 1.6, there might be a slight issue. So enough talking. So now we'll restart and run everything. And let me get a Sudoku grids. Okay. Just ignore the cable. That's just my microphone. Okay, apparently it has processed the image. And something wrong is here. Just give me a second. So it said that grid is not defined. Oh, that must be the... Can't find it anywhere, so let me do a Control F. Yeah, we don't need that. Yes, actually, we need that, but... Oh, because I have the grid as a parameter. Oh, that's why. Oh, okay. Actually, it was a bit wrong to say the peak image into the classify, because in the peak image that we have, we only have one unique value for Sudoku. So actually, let me get rid of the if statements and list name, etc. We all get rid of that. Actually, we can remove this as well. Okay, so now we can remove this because we just want the image value. What now? Okay, this is a bit annoying. I didn't remove the grid from the parameters. I believe we'll have to run again. And no. Okay, I think this image array should be cell. All right, just let me have a quick check.
5 minutes later.
And again. Okay, just replace image size by 100, no matter how we do it. And anyway, I will upload this notebook to my GitHub, so you will have the updated version anyway. At last! Okay, so the first digit, which is a 4, is actually 4, and it is more than 90% sure. Okay, that's cool. So we have 9, 2. Just let me disable the scrolling. Okay, so we have a better view. So we have the 9, 2, 8, 7, 7. So to be honest, I thought it will have a confusion between the 7 and 1, and also the 9 and 8, because I have massive errors like this when I first started this project. So okay, this is not too great, but okay, we'll still consider as good. I believe that the other probability to have another numbers are really low, so we'll still have that. Yeah, and also, by the way, we don't have the 0 included. That is because it is an anti-cell, it doesn't have any contours. So I will do like sort of a cheat way to do this. I will just say, if this image doesn't have anything at all, doesn't have any contours to the text, just pop it as a 0. Well, that's a bit cheating because we are not using deep learning, but anyway, we are still using for 9 others images, so we are alright. So that is all for this video. So in the next video we will show how to get all these values in one Sudoku matrix so that we can solve it, and by using an algorithm which also will be shown in the next video. And I think we will soon wrap up this project. Thank you for your attention and see you next time.